Hey everyone, I'm back with another problem on the InterviewBit series on the topic arrays. So the problem today is minimum lights to activate. So let's read the problem statement first. So there is a corridor in a jail which is n units long. Basically, you are given an array of size n. The ith index of the array is 0 if the light at the position I is faulty, otherwise it is 1 if it is not faulty. Right, all the lights are of specific power b which is placed at a position x. It can light the corridor from x minus b plus 1 to x plus b minus 1. Okay, so let's say you are at position I. Okay, so you can it can light the corridor up to I minus b plus 1, and it can on its left light up to I plus b minus 1. Okay, perfect. Let's move forward. Initially, all lights are off. We need to return the minimum number of lights to be turned on to light the whole corridor, or tell if it is not possible at all. In that case, we need to return a minus 1. Okay, so here are the constraints. It's 10 to the power 5. Okay, let's move on. Let's move on to the test case. So we are given this array. So 0 means faulty and 1 means it is fine. We can light it up. Okay, 0 means faulty and 1 means not faulty. Okay, perfect. So the main idea here is we'll try to light up every position, right? We'll try to light up every position. So if I need to light any ith position, I can switch on any of the lights from I plus b minus 1 till I minus b plus 1. So if you have a light at position I, then you can light up to I plus b minus 1, and you can light up to I minus b plus 1. Let's just reverse engineer it. So you have light at this part. Can we light ith position? Yes. Similarly, if you have a light at this part, can you light up the ith position? Yes. So we have reverse engineered it and found out that if you have a light from this range to this range, then we can light up position I. Similarly, on the left side, if you have a light at this range, then you can light up the position I. Right. And which light to choose? So we'll follow a greedy approach here. Okay, so you can pick any of the lights. Let's say any of the position can have one between them, but which light to pick up, right? That's the main idea of the question. So which would I pick up? So I'll greedily pick up the rightmost light. Okay, why will I pick the rightmost? Because this would not only cover the ith position, but it would also maximize the forward coverage. Okay, so if I pick this index, it will not only satisfy my condition of lighting up the ith index, but it will also maximize the forward coverage of the lights, right? So at each step, we'll try to pick up the rightmost light which we have. Okay, let's try to dry run this key. Okay, so this is a faulty index, right? This is a faulty index. This is index 0. So we can choose any light from 0 minus 3 plus 1 and 0 plus 3 minus 1. So this is equal to minus 2 and this is equals to 2. Since we do not have a minus 2, we'll take the max of 0 and whatever element we get. Okay, since we start from 0, so 0 and 2, so I can choose any lights from 0 to 2, right? I'll check. So this is my range here, so I'll check, do I have a light? I'll start from the right and I'll check. I'll start from the right, I'll go until left, and I'll check, do I have a light in this range starting from right? If yes, then this will light up this index I. Okay, this will light up this index I, and not only just that, it would also light up until this part. So I can just shift my index from here to here. So now my current index I goes here. Perfect. So just by switching on this light, we are able to cover this part and this part. Perfect. So I'll update my answer to 1. Okay. Now we are at this index. Okay. Perfect. Now we are at this index I. Now I'll try to see. So what is this index number? 0, 1, 2, 3, 4, 5. 5. We are currently at index 5. Now we'll check 5 minus 3 plus 1 and 5 plus 3 minus 1. This becomes 7 and this becomes 3. So from where can I go? Either I can start picking the lights from here or here. So this is my range. So I'll start from right and I'll go till left. So I did found light at the first position itself. So in this case, I'll take this light and it would also light up this index I and also cover the forward range. So I'll also update my answer to 2. So in this case, the minimum number of lights needed is equal to 2. Perfect. Now let's move on to the next test case. We'll follow the exact similar process here, right? So we have this index. So the range for this is going to be, if I is equals to 0, so at what range I can pick up the lights? 0 to 2. How did this came? I plus b minus 1 and I minus b plus 1. You can choose any light in this range. Perfect. So I can choose any one from 0 to 2. But wait, so this is 0, 1, 2. So my range is from L to R. But we do not have any lights here. We do not have any lights here. This means that we cannot cover or we cannot light up this index, right? So in this case, the answer is going to be a -1 since we cannot light up the whole corridor. Okay. So this was it for the explanation. Now let's move on to the coding part. Okay, now let's code it up real quick. First, we'll get the size of the array, which is a.size. We'll have a pointer which will move forward at every step. Let's maintain I is equals to 0 and let's have an answer variable to store the minimum number of lights we need. Perfect. Now I'll have a while loop which will go till n, and this would denote every index or every position where the lights are. Now I need to get the leftmost. So this is going to be I minus b plus 1, right? But this can also go negative, right? So you need to take the maximum of 0 and this. Okay, perfect. Similarly, you'll have the rightmost part. For that you'll have I plus b minus 1, right? And similarly this can go out of bounds, so you need to take the minimum of n minus 1 and this guy. Okay, so now I've got the leftmost part and the rightmost part. Now I'll iterate till right is greater than or equal to left. Okay, and I'll check at each step if I found a light, which is if I found the element 1 at any index, that is a of right happens to be 1, then what I need to do is I need to pick the rightmost bulb, right? And how will I know I have picked it? Let's just maintain a boolean variable called found, assign it to false. I'll say found is equals to true and I'll break it off since we need only one single light to cover the position I, right? Perfect. And if I haven't found it, then I'll iterate till right minus minus. Okay, now I'll check if I've found the bulb. Or we can say if I have not found the bulb, then at this point only return -1. Okay, and if I found the bulb, then what you need to do is increment the answer, and also you need to increment the current index. And what would be the current index? The current index would be I is equals to right plus b. Okay, since the bulb you have picked would cover the left part, also it will cover its right part. So you'll move the current index to right plus B where you have found the bulb, right? That's it. We'll just return the answer. We'll run it once. Okay, the trivial cases are passed. Let's submit it. Yeah, so all the cases are passed. Perfect. Okay, I hope you guys understood the solution for this problem. We'll meet in the next video. Till then, take care. Okay, chalo, bye.